Welcome to Tech Talks. I'm Holly Scott. I have this distinct pleasure of having with me today Amir Danino from Inovventric. Amir, welcome. How are you?
I'm fine. Thank you very much for having me. It's a pleasure to be here.
Excellent to have you on our show. I have followed you with great interest for, gosh, well over a year now, and the technology is just so exciting. We first met at LSI, and you were one of the very unique organizations that bubbled up it, tackling
Yeah.
a challenge that few are going after, but no one's going after it in the way you are. And that's what really caught my interest is the simplicity of the Inovventric device. But before we jump into that, because I know there's a lot to talk about, as part of our offering here to our audience,
Yeah.
obviously I care about career. And I talk with people every single week that are interested in becoming a CEO at some point. And each road is unique, right? There's no straight line to becoming
Yeah.
who you are today. So could you share with us a bit about what brought you to Innoventric, maybe how you started and a little bit about your journey?
Absolutely. So I think that I will start by saying that my journey was not planned to be what it is or what it became eventually. I don't think anyone really plans to be a CEO. Maybe some do. I didn't. Um, it was a journey that started with working for good people. So people who were very creative, people who are very um, talented at what they do, and that always gives you a sense of, hey, I want to become that. I want to do something like that. I want to be able to do what he or she are doing. And that was part of my journey. So I worked for many, not many, but three good medical device companies that were very interesting at the beginning of my career. And besides being very interested in what I was doing, I was also very impressed with the people I was working for. So that probably influenced me to do something of my own. In addition to that, it's also a sense of mission, I think, that sent me down this road. Um, and this sense of mission is not because, when I went to school, when I went to study my bachelor's degree in biomedical engineering, it was I think a sensible, it was a good choice of what to study. It was interesting, but I had no sense of mission back then. But then 2 or 3 years later, my father became a heart patient. So my father was fortunate enough to get to the age of 45 and only then start a family. So I had a father who was, when I was in my 25 or 30s, um, my father was became a heart patient, and I just was a biomedical engineer. So I had the job of maybe going to these physicians or these hospitals with him. And it kind of showed me how important this is. And my father was a patient who received several medical devices, cardiac devices. So that became something that, was extremely interesting for me. I saw it not only from the engineering or the entrepreneurial side, I saw it also from the patient side, which gives you a more full picture of why to do this, why this is important. So I think these are the two main things which led me to become an entrepreneur and a CEO of a company.
Fascinating. And I don't want to minimize something you mentioned, your academics. You attended where did you get your bachelor's degree?
So I went to Ben Gurion University in Beersheba in Israel for my bachelor's. That's where I studied biomedical engineering. Later on in my career, I also had a master's in mechanical engineering from Tel Aviv University. So that became this is my education. But I think that there's a lot of education that happens, especially within the first years of your career. So I think that many places I worked for, the three great medical device companies I worked for, were also great schools for me.
Sure, it's really putting that into practice. And you mentioned very quickly the mentorship that you got, that really helped develop you. And I hear that consistently as people grow. They go to work for people. They don't go to work for necessarily a product exclusively or any other component that we go to work for. So that's really important for individuals who are selecting, especially early in career. Sometimes we counsel individuals to consider their academic choices and their first roles based on certain criteria. And the reality is the most important criteria to base those decisions around is who you're going to surround yourself with. Because that network that you start developing, they become your early mentors. They become your early guiding lights to what is next for you. You don't know what you don't see and what you don't experience. So I think that's a really important point because, look, you have an incredibly rich academic background. Israel is known for being an innovation capital in the world, yet the first thing you mentioned was some of the mentorship you got in those early years. So that's really neat, and I appreciate you reflecting on that.
Absolutely, and I don't mean to say that everything was perfect. I worked for the perfect working places, or I worked only with the best of the best. I think that many of the experience that we get and many of the things that we see in our careers, we should be able to say many times that, hey, I would do this differently. I would make this project work in a different way, or I would not do this, I would do that. And this is also very important. If the workplace that you work in allows you with that freedom to do something a little bit different, to be more, to be able to say, hey, I don't think this is going to work. I want to try something else. This is also a great way of developing yourself in your career, being a little bit, have forgot the word.
Like freedom and creativity and the ability to test the bounds a bit. Being in
Exactly.
that box, you can be limited. You can be limited. And
Yeah,
that's regardless of company size. That comes back to leadership. That comes back to the style of the team leader that you're involved with. Are they going to give you any autonomy to think outside of what's in front of you and develop it? So it sounds like you were able to explore and learn
exactly.
through those experiences.
Yeah, and put some critical thinking, into my work, and that was great.
That's excellent. So with your father's situation and being a cardiac patient in particular,
Mhm.
was it a valve issue? Were there valves involved? Because we're at you're in a valve company tackling the toughest valve, if I must add, or one of the
Yeah.
tougher valves anyway. Was that a situation where the valve itself
So,
sparked your interest?
so what I've learned through my father as a patient, but also through my career, is that eventually there's always a valve issue. If you're in your 80s and you're a cardiac patient, you're probably not getting, the best valve function of all your four valves. So there's going to be a valve issue. Whether it should be treated immediately or later on, that's another question. But I think that with my father, I kind of learned the basics. For example, when you're a cardiac patient, especially heart failure, which has several degrees to it, you don't have to be at the worst heart failure condition to experience heart failure and heart failure treatments. And I think the most frequent treatment for heart failure is diuretics. And one thing that I've learned, this was very interesting to me. My father, even in his late 80s, used to walk a lot. He would go out of the house 8 a.m., come back 12, and he would walk 1 hour in this direction and have a 2 hour meeting with some friends or a cafe or my mother, and then go back 1 hour by foot. And that was his fun. And that was keeping him, alive, happy. And when he started on diuretics, he started to calculate how many places he could stop, because diuretics makes you urinate
Yeah.
eventually.
Mm-hmm.
So he had to think where he would stop 3 times along the way to the cafe. And that made his fun part of the day not so fun.
Mm-hmm.
And he would do it much less, to the point where he did it, you know, once a month. And that was really, that's what makes you get older.
Mm.
And I saw that on my father. And you know, this magic word that physicians sometimes throw into the air, yeah, we'll give you some diuretics, looks and sounds like, hey, it's a no-brainer. We got a solution here. But this solution bears a cost. And these patients need sometimes something different. So that made me think, or get to know the basics of heart failure, basics of cardiac treatment. My father went through heart surgery. He got an implant in catheterization. So I saw the whole scope of cardiac treatments, and that was an education for me, not less than biomedical engineering bachelor's degree.
Mm-hmm. Well, the quality of life piece is something that we talk in generalities about, you know, and it's like it's a buzzword until it's not, kind of a thing. And this is a prime example of where a gradual decline can happen over time with these small steps and impacting your quality of life. And if you look back over, say, 4 years' time, your health can be dramatically different because of one subtle change. Let's add these diuretics, let's do this, and then all of a sudden his world changes, you know? So it's fascinating. I see that in every avenue of medicine. So I'm really grateful again for your focus in this area, because you know it's near and dear to my heart. Obviously, I have a personal passion for being here as well. So let's talk about Inovventric. So where did this idea come from? It's almost like one of these things where I think this was an aha experience. This must have been, at some point, there must have been a lightning rod that hit your napkin when you were sketching on it or something.
So, you know, many times we think about these moments as eureka, and you found something, and hey, this is the light bulb that lights up. And I think that for the vast majority of cases, this is gradual, you know, improvements that we make. And I think that, first of all, I had the pleasure, the real pleasure of working in valve with or on valve technologies for 10 years before I came up with the idea for Inovventric, before I started Inovventric. But in my time with mitral projects and my time on aortic projects and devices, I kind of wondered, okay, so I know mitral regurgitation, everybody was treating or trying to develop something for mitral regurgitation in the early 2000s. And I was thinking about what happens in the tricuspid, or what happens in the right side, or the mirror side of that mitral valve. And the answers that I used to get were, I don't think it's that important, from physicians, from surgeons, from interventional cardiologists. Hey, I don't think it's that important. It doesn't happen that often. And that put me, you know, put that thought about having to treat tricuspid, you know, at a lower pace. So I didn't get to it, or I didn't think about it as much because of it. But as mitral and aortic solutions became more available around the world, it started to the understanding of, hey, we're now treating the mitral, we're treating the aortic, and these patients are still not doing any better, or they're still requiring more treatment. And then all of a sudden, the tricuspid valve, which was referred to as the forgotten valve for a long time, became what everybody started to develop solutions for. And the reason is that nobody thought it was important or needs to be treated immediately before, or very few knew that it had to be treated and that it has an acute effect on quality of life and even life expectancy of these patients. And all of a sudden, this understanding sunk into the industry, and everybody started to develop tricuspid solutions. But at that point in time, it was clear to me that we, the engineers, have gone too far. We are developing technologies that are, maybe could be used in the hands of a very experienced engineer, but I don't think that the average interventional cardiologist got the education for using such highly technical, complex technologies. Sometimes procedures, and I would see that in my time in the industry or in cath labs where I used to visit. So I would see procedures that take anywhere between 2-3 hours, sometimes to 5-6 hours, just to put one device in. And that would be too burdening on the physician, on the hospital, on the health system, but first and foremost, on the patient that has to undergo general anesthesia for 6 hours, sometimes an echo probe down the throat into the esophagus for 6 hours. You get burns from that echo working for 4, 5, 6 hours. And it seemed to me that the solutions that we are offering the industry, that we are offering physicians, are too complex, and we need to make it simpler. And that led me to that aha moment where I saw that everybody at that point in time where I came up with the idea for the Inovventric technology, everybody was trying to put on the mitral and tricuspid valves the huge success of before, the aortic valve. So TAVR, everybody tried to take this TAVR and make it mitral adequate or make it tricuspid adequate. And the fact is that the mitral and tricuspid can be sometimes 3 times as big as the aortic valve. They're non-uniform, they're constantly moving. And this has led to a situation where we were already a decade into developing these technologies, and no technology was available on the market. Nothing reached the market, and we wanted to do something very different. So we wanted to stay away from the very difficult anatomical structure of the tricuspid valve. And we wanted to use vessels, just like the aortic valve in the aorta. We wanted to use the vessels which are present next to the tricuspid valve, which are the superior and inferior vena cava. They're round, they're circular, symmetrical, very easy to deliver into, very easy to deploy a device within them. So we wanted to do something there, and we offered to replace the tricuspid valve by actually adding a 5th valve to the heart. So there are 4 valves in the heart, but we're adding a 5th one. And the thought came from, hey, if I have a leaky faucet back home, I can close the leak on the faucet, just entrance or exit, but I can do it in the a tube leading to that faucet 1 meter behind. And that's what we're doing with the Inovventric technology, with the Trillium or Unica devices. We're actually blocking the leak 2 centimeters upstream. By that, we don't have to deal with the complex anatomy. We have a straightforward procedure taking less than 5 minutes to perform. Actually, we did a case this morning, 5 minutes implantation time. So that was the general idea of make it simple, allow the physician with something they can do in large quantities and high quality.
Fantastic. If you have the opportunity, anyone in the audience, to review videos associated with the current technologies on the market, you'll notice that the deployment, the mechanics, structure, the steerability, I mean, it's challenging to watch, much less perform. So you certainly need to have the skilled individual to pull this off. And you're manipulating an already faulty valve with the idea of trying to improve outcomes. Where if you look at the Inovventric device, as Amir mentioned, you've got deployment and case over essentially in roughly 5 minutes, because it really does create, I love your faucet example, by the way. I may have to steal that because that's just such a great visual.
Please do.
Yeah, and it really allows for the access to the water flow to be tapped into from a place that will work while offering, you call it a fifth valve. It really becomes the prominent tricuspid support at that point without the issues associated with the faulty one. So it's really, really unique, and that's what we like in medicine. In general, the market goes for things that are simple, effective, work well, and can be used by individuals that are not exclusively the top 1% of their game. You know, that's where we can truly make this an option for the general procedures that are associated with interventional cardiology. So it's quite exciting. It's quite exciting. So where are we right now? You're in clinical cases, including today and including all of this week. So in the big picture, how close are we to having this available for patients?
So we are just now discussing the large study that will make this available on the market eventually. So this is not very far from us. We are talking with regulatory bodies, whether in Europe or the United States, to make this investigation to have a clinical trial, probably a randomized clinical trial as required in the industry, and to investigate how this works compared to the options that these patients have. And many times these patients don't have any other option. So many times they've been treated before, but it didn't work, whether by surgery or whether by interventional procedure. And again, this is one of the benefits of doing something not on the tricuspid valve, because sometimes there's already a device there. Mm-hmm. So the area there is already occupied with a device that doesn't work anymore or didn't have a huge effect on the patient. Now, you cannot put a second device on a previous device. So you have to do it elsewhere. So we're doing that. And we're bringing these patients into what now is becoming the last steps or the last phase of an early feasibility study in the United States. We've completed a European first-in-human study. We're treating so many patients through a compassionate use route. I'm now in Ottawa, in Canada, through the Special Access Program. We treated a patient today, again, 55 years old, has no option, coming back to get paracentesis, which is actually getting punctured in the abdomen, taking out fluid, sometimes 6-8 liters of fluid, and that happens every 8 weeks for that patient. So no treatment option for that patient. We came in this morning and we reduced immediately on the table the venous pressure, which creates or necessitates these punctures. That was reduced immediately. So this is something that we do a lot. It's part of the clinical experience that we have. In addition to studies, we have a lot of compassionate uses that we perform. And I hope that within 2 or 3 years' time, we will have this available on the market.
Yeah, so there's a couple things in there for the general listener audience to understand. And the tricuspid, the patient who's addressing a tricuspid issue likely has comorbidities, likely has other issues going on. There's a high proportion of that. In fact, statistically, what do we have cases annually? What's the market size for a tricuspid?
So there are 250,000 new cases of significant TR in the US every year.
It's significant. Not only is it significant because it's a large number, it's significant because that is a population that is then, if they're getting an option, they're getting an option currently that takes hours and has a very complex profile of the procedure itself. So when you simplify that already sick patient's time on the table, and you simplify the actual procedure and even the hardware, so to speak, that's left behind, all of that can improve our outcomes. And that's very encouraging to me, the layperson. I'm obviously not working for the FDA, but that's me from an understanding of the market and seeing over the years what works. I've seen this in other areas, doing this time and time again, and watching new technologies creep in. It reminds me a bit of when stents first came in and they were trying to tackle restenosis, right?
Yeah.
And they were tackling it with really invasive and other treatments that were going in and going on top of the stent. And so it was almost like we had this problem and we had another problem on top of the problem. So because the problem got more complicated, so did the solution. Instead of stepping back and saying, I wonder if we just wrapped the stent in something that could prevent restenosis and get it right the first time, and boom, overnight, the market of treating restenosis with an electric current and with the ways that they were doing it were gone. They had no market. It was crazy. But this is where your product fits in my mind, is I've seen where these engineering competencies go so far downrange with trying to solve the add-on problems on top of the add-on problems. It's refreshing to step back and say, well, what if we just did this? What if we just created a different opening for the faucet?
Absolutely. And we engineers, I recommend every physician working with engineers to just tell them to do it in a more simple way, because I see physicians many times they are reluctant to say, hey, this is too complex for me, or this is too complex for my team, or this is too burdening on my hospital, my department. I cannot do a 6-hour procedure. I cannot do a 3-hour procedure. I encourage you to bring me a better or a simpler solution. And many times this competition of, yeah, I did this crazy procedure where I was able to do this within just 2 hours, and this heroic cases, it's nice for the podium, but I think that if we want to treat many patients and we want to treat them in a repeatable manner that many physicians and many hospitals around the world can really implement, then we should, as engineers, we should try to keep our solutions simple.
How big is your engineering team currently? How many people are working on this?
So we have 25 people at Inovventric. Not all of them are engineers. We have physicians. We have an amazing clinical team. We have an amazing R&D team. We have an amazing manufacturing department. But it's a team effort, and I think that even if you're not an engineer, the amount and quality of input that is put into this, I see all 25 as, the people who created this technology. Even if eventually your job title is that you're assembling a delivery system, your inputs are influencing the technology. For example, we really require that the clinical team will be able to address any technical issues with the device, and vice versa. We require that if you're an R&D engineer, you'll be able to walk into a cath lab and just give your inputs to the physician, to the interventional cardiologist, be able to actually talk the language that physicians are talking, and be able to see, understand, influence, a clinical procedure, which is not the typical, the mechanical engineer does not learn in university how to treat vena cavas or what's the tactile feeling of a heart muscle and so forth. But if you're developing something that is going to be implanted into the heart eventually, I want you to go to animal studies. I want you to go to clinical studies. I want you to see the entire big picture.
I can see why that's really important. Is your team all in Israel at this point? Where is everyone?
So we have one here in Ottawa, one employee, but other than that, yes, everybody's in Israel, and we travel.
You travel. Yes, I know. And I know we're going to be bringing some new team members over the next 12 months as we continue to
Absolutely.
expand and look at that. So as individuals, especially in the structural heart space, you do not want to miss following Inovventric and their progress, because it's definitely a unique approach that has an option for many, many patients, otherwise not being able to be treated. How about the materials? Is this something that will need to be replaced after 10 years if the patient is fortunate to continue to do well and they're in a state of, especially younger patients? I'm just curious, was that factored in?
So this was factored in a process where we didn't start with uh, a great lifetime management solution.
Mm-hmm.
And this is something that I think if you're dedicated to patients, to bringing a solution which is real, and you don't fall in love with your initial solution and you always protect that, even when you know that it's not the best in some aspects. So we continuously improve the technology. And along the way, one of the things that I did not have a good answer for was how are we going to treat the patient population 10 years after the first implantation with the Inovventric device. And this has led us to develop a second generation of the technology that really creates a situation where you can, not by replacing the materials, but by doing something which is known as a valve-in-valve procedure, we created a device, the Unica device, the second generation of our technology, which, by the way, we implanted today here in Ottawa. So this technology allows us to have a valve-in-valve in any one of the SVC or IVC valves at any point in time. It's designed, it's tested for it. It's very simple to do with any off-the-shelf valve. But also, we created a technology that allows any future to. So many times these patients need pacemaking. Many times these patients need a transeptal procedure for something happening on the left side of the heart. So we brought a holistic solution for anything happening in the cardiac chambers or within the heart, so that our solution does not exclude anything else and does allow lifetime management of these patients.
That's powerful, because so many of the options, just as you said, they have the legacy devices, and they're very, very difficult, if not impossible, to retreat. And let's face it, the heart is a changing and evolving organ, and over time, there's going to be needs for adjustments and for potentially, especially if we're talking about the younger patient population, as they continue to grow. So that's excellent. I'm thrilled to hear that. So in terms of where you see the organization, you've been leading the company for a significant amount of time now. You're driving an incredible culture and passion for it. What are you most excited about over the next several years?
So I think I'm most excited about um, getting to larger numbers of patients, getting to new geographies, and also on a smaller scale or on a smaller level, although it's not that small for me, it's really exciting still for me. I really enjoy the challenge of working with a team, managing a team, and making this team really excellent. And it's a challenge. It's not that easy. It requires continuous attention. Um, but I really like this part of my job. This is something that I wake up every morning to with a lot of enthusiasm and gets me going. So, yeah, working with my team, developing this team, getting this team larger. You talked about increasing the or having new areas or new geographies where we have employees at US, for example, Europe. So doing that, this will be a new step for me, specifically for Inovventric. We're very much looking forward to that. Um, and yes, treating more patients, treating them well, having this available to as many patients and physicians. By the way, we enjoy watching physicians get exhilarated with the clinical result and with the simplicity of the procedure. So we do that for them as well.
I can imagine that must be so fulfilling for them to see these patients that likely they've been seeing for challenges for some time and then actually have a solution that works simply. That's got to be incredible. It's interesting, every time we talk, every time, I think about what it's like for your team, for your organization, and what it would be like for individuals that I talk with every day about how they develop their career. And we encourage people when they're evaluating opportunities to consider, we call it the 4 pillars. The product, what are they making? The market, is it a market that's expected to grow? The mission, it's got to be one you can get behind, and leadership. Because all of those pieces, you need 4 pillars to support a healthy organization. If one of those pillars isn't right, you got an issue. And you have such strong pillars that I want to not only compliment you, I also want to share that the reasons that I'm pointing to this, not because you are you're just a remarkable individual from your own right, but you've had very low turnover in the last, 10 years, you said? I know your team has been with you a long time, and they are
Yeah.
slugging it. I mean, that's not typical in a young company. You've got a CEO who's managing clinicals on the road. How much do you travel?
I
Two?
think about 40, maybe 30, 40% of my time.
You're gone a lot, and you've got a team on the other side of the world many times that
Yeah.
needs to self-manage and drive. And the only reason they can do that is because you've instilled in them the ability and the authenticity and trust to do so. So these pillars are really important. And the market, when you're thinking about where you go career-wise, you want to look at where the market's headed, where the trends are, and that's where what people care about, what's significant, where the money's going, and then where you're going to have interest, and your interest and where you're going to flourish tend to be with a team, coming back to the people and who you surround yourself with, and they help bring you up. So I'm just thrilled for you, Amir. I know I'm catching you you say it's been a busy week. I'm saying it's a normal week for you. It seems like every week is
Hopefully
busier.
next week will be less normal.
Less normal, hopefully. Maybe you can
Hopefully.
get, well, how many hours of sleep? 4 instead of 8? Or 6
Yeah,
to
so
8?
on the road, it's typically 4 or 5 because hospitals start very early. We typically travel in between sites over, afternoons and nights. So, but I don't complain. It's fun. We
Oh,
enjoy it.
you're getting great results. Well, I so appreciate it, and I'm really thrilled to watch Inovventric, thrilled to be your partner, and thrilled that you were able to join us today, especially after the long day you've had.
Thank you very much. This has been a pleasure for me, a great conversation, and thank you for having me here.
Absolutely. And to everyone that is listening, thank you for your time. Thanks for joining us on Tech Talks, and we'll see you next time.